Mabuhay. Welcome to another series of Sir Jeryl Explains. Today, we will learn all about the topic, heat and temperature. This will be lesson 3. So, let's get right to it. Are heat and temperature the same? Let us tackle and dig deep. The common thinking of people to heat and temperature is that they are the same in physics, they are related to each other, but not the same. Heat is a form of energy that transfers from a body of higher temperature to another body of lower temperature. Heat transfers from one body with a certain temperature to another body with a different temperature through conduction, convection, and radiation. Convection, the transfer of heat through a fluid, liquid, or gas caused by molecular motion radiation, energy that is radiated or transmitted in the form of rays or waves or particles. Conduction, the transfer of heat or electric current from one substance to another by direct contact. There are many examples of heat. If we put a spoon in a hot cup of coffee, the heat from the water will be transferred to the spoon with conduction PL. Another example is, when it is cold, you tend to stay close to the fireplace or a bonfire. As you stay close to fire, thermal energy is transferred by radiation. To further understand heat, we must know that the unit used for heat is joules, J. There are also other units, such as calorie. ATM stands for atmospheric pressure, and the normal atmospheric pressure is 1 atm. Do take note that, to avoid confusion, a calorie is not used to refer to an amount of heat. It is used by a dietitian to specify the energy content of food. Now let us continue to temperature. Temperature is the measure of hotness or coldness of a body, object, or substance. In a scenario, if we have a fever, you usually how hot by basically putting your neck or your forehead. This is very typical for everyone, as high temperature usually indicates a fever. The normal body temperature is 37 degrees Celsius. If that goes higher, something may be wrong. There are many accurate ways to measure temperature, such as a thermometer. Temperature describes the average kinetic energy of molecules in an object or a substance. The higher the kinetic energy, the faster the molecules move because the temperature is higher. The common measurements for temperature are Celsius, Fahrenheit, and Kelvin. The important people in temperature or in their discovery are the following. Anders Celsius introduced the Celsius scale in 1741. Daniel Gabriel Fahrenheit introduced the Fahrenheit scale in 1724. To better understand temperature, both scales used the freezing and the boiling points of water as reference points. The Celsius scale presents that the freezing point of water is 0 degrees Celsius, while its boiling point is 100 degrees Celsius, them having 100 intervals between two reference points. The Fahrenheit scales presents that the freezing point of water is 32 degrees Fahrenheit, and the boiling point is 212 degrees Fahrenheit, having 180 intervals between two reference points. Now unto the Kelvin scale. Lord Kelvin introduced the third scale, which is Kelvin. This scale is based on absolute zero, corresponding to 0 Kelvin, which is the lowest possible temperature, and when the molecule's lowest energy. The Kelvin scale cannot have negative temperature. The freezing point of Kelvin 273. Kelvin, the boiling point, is 373 Kelvin. The temperature difference is 100 Kelvin. When a temperature of a substance changes, its molecular structure and movement also change, which results in what we call phase change. There are different types of phase changes or transitions, such as melting, solidification, evaporation, and condensation. Melting is the process that causes a solid to change to its liquid state. The amount of heat required to produce this change is called heat of fusion. Solidification or freezing is the process of changing liquids to solids. Evaporation is the process of changing liquid into gas. Condensation is the change of water from its gaseous form into liquid. Sublimation is the process of transforming a substance from that solid phase directly to gas state without passing the liquid phase. This requires additional energy. Deposition is the process of transforming a substance from gas to solid without passing the liquid phase and requires a release of energy.